Welcome to G Fun Facts Online, where today we're diving deep, not just into history, but into the very essence of color. Imagine a hue so captivating, so ahead of its time, that it's journeyed 5,000 years to find itself at the cutting edge of modern technology. We're talking about Egyptian blue, the world's first synthetic pigment, a testament to ancient genius that's painting a brand new future. Let's rewind to ancient Egypt. Blue was a big deal. It was the color of the heavens, the life-giving Nile, the divine. The Egyptians were desperate to capture this celestial shade for their art and religious artifacts. But natural blue minerals, like lapis lazuli or azurite, rare, incredibly expensive, and a nightmare to work with, this scarcity didn't deter them. It fueled them. Around 3,300 to 3,100 BCE, they did something extraordinary. They invented blue. They called it *HSBD-IRET, meaning artificial lapis lazuli, a clear sign they knew exactly what they were achieving, a synthetic marvel. So, what was this ancient recipe? Chemically, Egyptian blue is calcium copper silicate. To make it, ancient artisans were like early chemists. They mixed silica, likely from sand, lime, probably an impurity in the sand or alkali, a copper compound, perhaps malachite or even bronze shavings, and an alkali like natron or plant ash, which acted as a flux. This concoction was then blasted in kilns at temperatures between 800 and 1,000 degrees Celsius. What emerged was a glassy blue material, often called blue frit, which was then ground into a powder. And here's a cool detail. The finer they ground it, the paler and more ethereal the blue. Coarser grounds gave darker, richer shades. The earliest traces of Egyptian blue pop up around the 4th dynasty, think 2500 BCE, on limestone sculptures. By the New Kingdom, around 1500 BCE, it was everywhere. Tomb decorations, wall paintings, even furnishings. It wasn't just an Egyptian secret either. Its popularity spread to Mesopotamia, across the Mediterranean, and all the way to the Roman Empire, where they called it *ceruleum*. The Roman writer Vitruvius even jotted down the manufacturing process in the 1st century BC. But, like many great things from antiquity, after the fall of the Roman Empire around the 4th century AD, the recipe was largely lost for centuries. Fast forward to today, and science has pieced together the puzzle. Researchers have meticulously analyzed ancient samples, figuring out the exact ingredients and firing conditions. Teams, like one at Washington State University, have successfully cooked up batches of Egyptian blue, experimenting with different raw materials, heating times, and cooling rates. It's not easy, though. Get the temperature too high, above 1050 Celsius, and the pigment destabilizes. Too much lime, and you get a greenish hue. Too much copper, and other copper oxides form. It highlights just how skilled those ancient chemists were. But here's where the story gets truly mind-blowing. Egyptian blue isn't just a pretty color. Scientists at Lawrence Berkeley National Laboratory discovered something incredible. It absorbs visible light and then emits light in the near-infrared range. And this isn't just any glow. It's exceptionally strong and lasts a long time. This unique property has opened up a Pandora's box of modern applications. For archaeologists, it's like having X-ray vision for ancient art. They can detect traces of Egyptian blue on artifacts where the color has faded completely, revealing hidden details on statues from places like the Parthenon. In medicine, because near-infrared light can penetrate human tissue better than other wavelengths, Egyptian blue could lead to more detailed and safer medical imaging. Its luminescent properties are also catching the eye of folks in telecommunications and laser technology. Think about it for security inks. Its unique optical signature could make forging money or documents much harder. And it doesn't stop there. Want cooler buildings? Egyptian blue can be used in construction materials. It absorbs sunlight and re-emits it as harmless infrared radiation, potentially slashing air conditioning bills. It might even boost the performance of solar panels. Forensic scientists have found that micronized Egyptian blue powder is great for revealing latent fingerprints, especially on tricky surfaces. Perhaps most excitingly, scientists have discovered that Egyptian blue can be broken down into nanosheets, 1,000 times thinner than a human hair, just by stirring it in warm water. These nanosheets retain that amazing near-infrared luminescence, opening doors for advanced microscopy, and maybe even tracking in agriculture. And the best part? It's made from common, inexpensive stuff: calcium, copper, silicon, and oxygen. The story of Egyptian blue is a stunning example of how ancient ingenuity can echo through millennia to inspire our future. What started as a quest for a divine color to adorn pharaohs' tombs is now paving the way for breakthroughs in medicine, energy, and technology. It's a vibrant reminder that the past still holds secrets, and sometimes, the oldest ideas can be the most revolutionary. As research continues, this 5,000-year-old pigment is set to color our world in ways its creators could never have dreamed. Thanks for tuning in to G Fun Facts Online.